Let's continue with chapter 3, example 3.18. Right here, the question is telling us how much it's going to cost us to run these different items in the house, given that the rate or the price for kilowatt hour it's 11 cents per kilowatt hour. So it says that if we run the AC for 15 hours, it consumes 860 watts. The blow dryer consumes 1000 watts per 10 minutes. The clock is 2 watts and is run for 24 hours. The dryer is 4000 watts and it's run for 1 hour, and the dishwasher is 1200 watts and it's going to be run for 45 minutes. So the first thing we need to do in order to solve a problem like this is first you have to make all the watts into kilowatts and all the time into hours. Why is that important? So that we can just multiply them out, and that's going to give us the kilowatt hour usage, and then we can multiply it by the price, in this case 11 cents, so that we can see how much it's going to cost us, what is going to be our electric bill. So let's start. The first thing, we're going to take the AC, it's 860, so 860 divided by 1000 give us a kilowatt. So in order to get the unit kilowatt hour, we just multiply them. In this case, the time is already in hours, so we just multiply, we get 12.9 kilowatt hour. And we continue doing that with every single one. So in this case, 1000 watts is 1, and then we have 10 minutes. We have to take the minute into the hour, so we get 10 minutes is equivalent to 0.16667 of an hour. So we just multiply it, and then we get the kilowatt hour. We continue doing that until we find every single one: the clock, the dryer, the dishwasher, and then we are going to add up every single one. We are going to take the 12.9, the 0.167, 0.048, the 4, the 0.9. It's going to give us a total of 18.0147 kilowatt hour. Now, how much is going to cost me to do that? If I multiply that by the rate, which is 11 cents, it's going to cost me $1.98 to run that. So that's how you would solve, that's how the Edison, the electric bill companies, bill us for our electric usage. On 319, it says calculate the power in each of the 3 different circuits. So right here, rather than giving us a problem, they give us an electric circuit, and they're gonna ask us find the power, and they're going to give us different quantities, and the purpose is so that we practice Watt's law. In Watt's law, we can find the power using voltage, resistance, and currents. So in this case, this says in number 8, they're giving us the voltage and they're giving us the current. So what is the power? So we can solve for the R and use that formula, but we can use the fact that power is also defined as V times I. So we have 20 watts. In number V, they are giving us the current and they're giving us the resistance. So in this case, we don't use V times I, we use I squared times R, and that's gonna give us 188 watts. On C, they're giving us the voltage and they're giving us the resistance. So again, we cannot use the P equals VI, we gotta use the form of the Watt's law, where we only need voltage and resistance, and then we solve for the watts. How do we go from this to here to that? We solve for the quantity that it is missing using Ohm's law, and then we plug it in there. And that's how we do it. In 321, It says choose inadequate power rating for each of the following circuit representations. So power rating, the standard power ratings are 1/8, 1/4, 1/2, and 1 watt. Those are the standard. That's how you would buy it off the shelf. If you want some other power rating, then you will have to send it to be custom to your needs, which means more expensive, right? So we usually stay with the custom, with the standard values, unless you are medicine or the government, right? They can get whatever they want. So the values right here are just in decimals. These are fractions. So here it says what is the power rating for this resistor right here. So I need to find the power, right? I have the voltage, I have the resistor, so I use this formula. I plug it in and I get 0.833 of a watt. In that case, what you need, you will choose the 1 amp, which will be 1 watt. For number B, we have the current and we have the resistance, so you will use this definition of the power, and then you will use multiplier and you get 0.1, so we choose the 1/4. It says the related work right here, it says we have a 1/4 of a watt resistor that it is a 1 kilo ohm connected to a 12-volt battery. Will that overheat? So what we have available, it is 1/4. So let's calculate what would the power rider be. So so if we do that, we are going to get 1/2 watt. It'll be, if we were to plug in the values here, no, excuse me, it says, the question actually says a certain resistor is equivalent to dissipate 0.25 of a watt. What standard rating should be used? So if it is, if you are indicated that your resistor can dissipate 1/4, we will go to the one above, because of the tolerance, we need to be consistent with that and understand that we don't want to be at 1/4 if 1/4 is what it needs to be deal. So let's stop right here.